Hello everybody, welcome to topic number 27, rationalizing denominators and numerators of rational expressions. Today we're going to show you how to rationalize both denominators and numerators when they have one term and two terms. Often in mathematics, it's helpful to write a radical expression such as square root of 3 over square root of 2 either without a radical in the denominator or without a radical in the numerator. This process of writing this expression as an equivalent expression but without a radical in the denominator is called rationalizing the denominator. Again, we continue to assume that variables represent positive real numbers. So what they mean by rationalizing is they do not want a square root in the numerator or the denominator. And typically in higher math, we use the denominator as it. They do not want to have a square root in it. So we have different techniques to doing it. And it all stems back to what happens when you multiply a square root by itself. Let's say you take the square root of 3 times the square root of 3. Since they're both in the square root, we can multiply them. We would get square root of 9. But square root of 9 is simply 3. So really, if you multiply any two numbers that are in the square root goes away. And it holds true for all numbers. The square root of 6 times the square root of 6 is the square root of 36, which is just 6. So we're going to use this idea to help us go through and rationalize the denominator or the numerator. We'll start with numerators and denominators that have one variable or one sort of term in it, but then we're going to move to two terms. When we move to two terms, we'll identify something called the conjugate. The conjugate is simply the opposite. If I have A plus B, then the opposite would be A minus B. Using this conjugate, we can go through and rationalize. Let's show you some examples. And for these, we're going to rationalize the denominator, which means we do not want a radical in the denominator. We're okay if it's in the numerator, but it cannot be in the denominator. So what we're going to do is we're going to take the radical that's in the bottom, in this case square root of 5, and multiply both the top and the bottom by it, because whatever we do to the bottom, we have to do the same to the top. 3 times square root of 5 is just left 3 square root of 5. And now we know when we multiply the radical by itself, the radical goes away. So square root of 5 times square root of 5 is just 5. Now the bottom doesn't have any radical in it. We check to see if 3/5 will reduce. It does not. So this is my final answer. We'll do the same thing for B, except remember, we can split it up. And the square root of 1 is just 1, so we'll write it as that. But now I've got to get rid of the square root of 7 in the bottom. So I'm going to multiply both the top and the bottom by square root of 7. 1 times square root of 7 is just square root of 7. And square root of 7 times square root of 7, again the radical goes away because that's really square root of 49. The square root of 49 is 7. This would be my final answer. Here we've got a cube root. Now with a square root, we multiply it by itself twice. But with a cube root, we actually have to multiply it by itself 3 times. So I'm going to do this, but then I'm going to do a third one. Because again, my job is to get a cube root. I need the same number 3 times. So at the top, I've got 6 times the cube root of 4 times the cube root of 4. The 6 will still be at the top, but the cube root of 4 times the cube root of 4 is the cube root of 16. And then at the bottom, we have a 4. Now, we do need to check and see if we can simplify the cube root of 16. So I take that off to the side, and I see that 16 is 4 times 4. And that's really 2 times 2 times 2. I have a set of 3 2's and 1 2 left over. So this would become 6 times 2 to the cube root of 2 all over 4. And 6 times 2 is 12, cube root of 2 over 4. Finally, we have this 12 over 4 on the outside. 12 divided by 4 gives me 3. So my final answer here would be 3 cube root of 2. So don't forget, we still have to check and see if we can simplify these as we do them. For my last one here, I've got square root of 18x, and I'm actually going to take a look and see if I can simplify that right away. I know that the square root of 18 is really 3 times 2 times 3. 3 times 3 is 9, times 2 is 18. So I have a pair of 3's with a 2 left over, and the x won't change here. So I can rewrite this as 5 with a 3 on the outside and a 2x here. Now I'm going to multiply it by its radical on the bottom. And I only have a 2x here, so I'm going to multiply both the top and the bottom by the 2x. 5 times 2x is 5 square root of 2x. On the bottom we have 3 times 2x after the radical goes away. And then 3 times 2x gives me 6x. 5 over 6 doesn't reduce. These x's can't cancel because this one is under the radical. So this would be my final answer. Again, we're okay to have a radical in the top when we rationalize the denominator. We just cannot have a radical left in the bottom. Let's try again. I've got negative 7 square root of 3 over square root of 11. So I'm going to multiply both sides by square root of 11. Negative 7 square root of 3 times square root of 11. We're just going to multiply the radicals. So I have negative 7 square root of 33, and here the 11's disappear. 7 over 11 are both prime. 33 is just 11 and 3, which are prime. So this cannot simplify any further. I'm going to rewrite this as 2 separate square roots. I'll go 23a over square root of 2b. 23 is prime, so it won't reduce. Same thing with 2. And I'm going to multiply everything by the square root of 2b. At the top, this becomes square root of 46ab. And at the bottom, the square root goes away and just leaves me with 2b. 46 is only 23 and 2, which are both prime, so that doesn't break down, and neither does a and b. I can't cancel out the b's here because this one's under the square root, and the same thing with the 46 and the 23. So this would be my final answer. Again, I've got a cube root here. So all that means is that I have to do it a total of 3 times. So I'm going to multiply the denominator twice more, and I'm going to do the exact same on the top. So as I do that here, on the bottom, it goes away. So I should just have 5y to the 4th left. At the top, we'll multiply everything together. We have the cube root of 10 times 5 times 5. 10 times 5 is 50, times 5 is 250. And then I have an x and a y fourth to the y fourth is y to the 8th. But we can definitely simplify this here because we know 250 is really 25 times 10, and 25 is 5 times 5, and 10 is 5 times 2. So I have a set of 5's with a 2 left over. So this will become 5 on the outside with a cube root of 2. The x still stays on the inside, but I also have 8 y's. 8 divided by 3 is 2 with the remainder of 2. So 2 of those y's will come outside, and 2 of those y's will still stay on the inside. I still have 5y to the 4th on the bottom. And now when I look to see if I can cancel anything out on the outside, I have 5 on the top and the bottom. Here I have 2 y's and here I have 4. So both of these y's will go away, and 2 of these y's will go away. So I'm left with the cube root of 2xy squared over y squared. These y squareds can't cancel because this one's inside the radical and this one is not. So that is my final answer. So again, we're going to rationalize the denominator, but now at the bottom we have binomials. And this is where that conjugate is going to come into play. And what we're going to do is we're basically going to take the bottom again, but we're going to write it with the opposite sign. So here I have 5 square root of 5 minus 4. So I'm simply going to multiply it by 5 square root of 5 plus 4. And same thing at the top. Off to the side, we're going to show you why we do that. Let's say we had a plus b. Well, if I have a minus b, which is its conjugate, and I FOIL it out, I have a squared minus ba plus ba. And then here I've got negative b squared But what happens to the middle here? I've got negative BA plus BA. It cancels. It just leaves me with the first term and the last term squared. And if the first term squared is the square root, it's going to go away. So when we do the conjugates, we only need to multiply the first two and the last two together. At the top, we've got 2 times both of these. So 2 is going to go to both of these. 2 times square root of 5 is 2 square root of 5, and 2 times 4 is 8. At the bottom, square root of 5 times square root of 5. It's the same square root, so it goes away. That's 5. Negative 4 times 4 is negative 16. These won't combine at the top, but at the bottom they do combine. 5 minus 16 is negative 9. I don't have a radical on the bottom, which is good. This is 2/9, that won't reduce, and this is 8/9, so that won't reduce. So we can leave this as our final answer. We can also bring the negative to the top if we want, like this, and write it as our final answer as well. Either of those is acceptable. We'll do the same thing for B. Again, the bottom is a binomial. So we're going to multiply it by its conjugate. Here it's square root of y plus 3. So now I'm going to do square root of y minus 3 on both the top and the bottom. Here I'll distribute the negative 6. Negative 6 times y is negative 6 square root of y. Negative 6 times negative 3 is 18. Here, square root of y times square root of y is simply y. 3 times negative 3 is negative 9. Nothing else we can really do to this, so we will leave this as our final answer. Again, when we rationalize, we just want to make sure we don't have any radicals left and wherever we're doing it. In this case, since we're rationalizing the denominator, we do not want any radicals left in the bottom. Let's do it here with this problem. So again, we're rationalizing the denominator. So it's only the denominator we care about. So the denominator here is square root of 3 plus square root of 2. The conjugate of it is square root of 3 minus square root of 2. At the top and the bottom, it's really just a FOIL, except the bottom we'll do our special trick. So at the top, we'll go through and FOIL this out. Square root of 2 times square root of 3 is square root of 6. Square root of 2 times negative square root of 2 is negative square root of 4. 4 times 3 is square root of 12. And then 4 times negative square root of 2 is negative square root of 8. On the bottom, they're conjugates. So we'll just do the first and the first, and the last and the last. Square root of 3 times square root of 3, the square roots go away, so that's just 3. Square root of 2 times negative square root of 2, the square roots go away, but positive and a negative make a negative, so that's negative 2. We can simplify a couple things. This and this we can simplify. The square root of 4 is simply 2. And the square root of 12, if we break it down, is 4 times 3 and 2 times 2. So we have a pair of 2's and a 3. So that's simply 2 square root of 3. And we could also break down the 8, because 8 is 4 times 2, which is 2 times 2. So this would become 2 square root of 2. 3 minus 2 is 1. So we really don't need the denominator anymore since it's 1. Nothing here will combine. Nothing is like radical. So this will be my final answer. One last time. Again, we're rationalizing the denominator. So all we care about is the denominator we're getting rid of. So we'll do 3 square root of x plus square root of y on the top. And the same on the bottom. 3 square root of x times 3 square root of x. They're exactly the same. So 3 times 3 gives me 9. Those have to multiply because they're outside the radical. Square root of x times square root of x. The square root goes away. It just leaves me with x. 3 square root of x times square root of y is 3. And then on the inside are both the x and the y. Negative 2 times 3 square root of x. Negative 2 times 3 is negative 6 with a square root of x. And negative 2 times square root of y is negative 2 square root of y. Here again, we'll do the first and the first and the last and the last. This is like the first one we did. 3 times 3 is 9. The square root of x times the square root of x is simply x. And then negative square root of y times square root of y. Negative times positive is negative. Square root of y times square root of y is just y. Nothing up here can combine. This has both x and y, and nothing else does. This doesn't have a radical. This is just square root of x, and this is just square root of y. So we will leave this as my final answer. So again, use that idea of a conjugate when you go through and you have more than one term wherever you're trying to rationalize. Here we're going to rationalize the numerator. So we're going to do the exact same thing, but now we just don't want a radical left in the numerator. So for the first one, it's square root of 5 over square root of 2. We're going to get rid of the numerator 1, so this time I have to choose square root of 5 is what I multiply by. Square root of 5 times square root of 5 is 5. Square root of 2 times square root of 5 is square root of 10. And if we're rationalizing the numerator, that is how we can leave our answer. Square root of 2x to the 7th. Well, to simplify this a little further, we know x to the 7th. 7 divided by 2 is 3 with a remainder of 1. So I could bring 3 x's out, and on the inside there's still a 2x. And here is an 8. So I'm only going to multiply everything by square root of 2x. At the top I've got x cubed, and then the 2x is left after the square root goes away. And on the bottom we have 8 times square root of 2x. Now this we can multiply. X cubed times x to the first. That's simply 2x to the fourth over 8 square root of 2x. And then 2 over 8 can reduce. We know 2 over 8 simply equals 1 over 4. So this goes away and this becomes a 4, making my final answer x to the fourth over 4 square root of 2x. Again, rationalizing the numerator, we just can't leave anything in the numerator. Here we have a cube root. So again, whatever we do, we're going to multiply it 3 times. We're doing the numerator again. So we're going to multiply everything in the numerator times itself 3 times. And the same for the bottom. At the top, we simply have 6x squared after it's all gone away. And then at the bottom, we have the cube root of 5 times 6 is 30, times another 6 is 180. We have x to the fourth, and then we have a y. And then the only thing that could simplify in here is the cube root of x to the fourth. 4 goes into 3 one time with a remainder of 1. So this will become, so I go write this out, this doesn't change. We have 1x on the outside, and then on the inside is left with everything else. The 180, 1x still left on the inside because we had a remainder of 1 with a y. Here, 1x cancels, and it leaves me with 6x over the cube root of 180xy. This final problem, I'm going to simplify things a little bit further, and I'm going to do it in red as we do this. The square root of 16, we do know, that is 4. The square root of x to the 5, x can come out twice, and we would still have an x left over. And then we still have a y here. So the top becomes 4x squared x to the y. At the bottom, the square root of 4 is 2. And then we have a square root of z. So the only thing I have at the top in the square root is an xy. So everything's going to be multiplied by the square root of xy. So at the top, I have 4x squared times xy. And at the bottom, I have 2. And then in the parentheses, I have x, y, and z. Then at the top we can simplify that further. We have 4x squared times x is x cubed with a y, and then we have 2 square root of x, y, z. 4 over 2 can reduce. The 2 will cancel out. The 4 becomes a 2, leaving me with a final answer of 2x cubed y over square root of x, y, z. Again, it's okay that in this case that we leave a square root in the denominator because we are rationalizing the numerator here. We just can't have any radicals in the numerator. Again, these are now binomials in the numerator, so we're going to multiply it by its conjugate. So for this one here, we'll do square root of 13 minus 1 on the top and the bottom. Square root of 13 times square root of 13 is simply 13. 1 times negative 1 is negative 1. At the bottom, we have 2 square root of 13, which is just 2 square root of 13. Then 2 times negative 1 is negative 2. So this will become 12 over 2 square root of 13 minus 2. And this can simplify. So if we kind of look at it this way, as we go through, we could factor out a 2 here because they both have a 2 in common. So I could take out a 2, and that leaves me with the square root of 13 minus 1 again. And then 12 over 2 would become 6. So 6 over square root of 13 minus 1 would be our final answer. We'll do the same thing for the last one here with f. The conjugate here is going to be for the numerator, so 3 plus square root of 11, and on the bottom 3 plus square root of 11. 3 times 3 gives me 9. Negative square root of 11 plus times square root of 11. Negative times positive is a negative. 11, square root of 11 times square root of 11, the square root goes away, and it just leaves me with 11. Negative 4 times 3 is negative 12. And then we'll have minus 4 square root of 11 here. 9 minus 11 is a negative 2. And at the bottom we have this. And again, we can go through and simplify this as we want. We can go back and kind of take out that negative 4 and have that 3 plus square root of 11 there, and realize that this will simplify. The negatives will cancel and make it become positive, and this will become 1/2. So this will become 1 over 2 times 3 plus square root of 11, or we can rewrite this as 1 over 6 plus 2 square root of 11. Either way there. But again, when we rationalize, we have to go through and understand. If we rationalize the denominator, we don't want any radicals left in the denominator. And if we rationalize the numerator, we do not want any radicals left in the numerator.